All right, students, today we're going to look at this idea of multiplying and dividing radicals. Now we're going to go back and use some properties that we've already seen at the beginning of chapter 11, and we're going to look at how to use the product and quotient properties of square roots. Now, sometimes we're going to put them together with commutative property. Remember, commutative property is where numbers switch places. We may use associative property, which means we can reorder the numbers, and distributive property. You remember distributive property back from chapter 1 when we would take the number on the outside of the parentheses and multiply it by the number on the inside. So we're going to see here, as I take care of these problems, we're still going to have numbers that are outside of the radical and numbers that are inside of the radical. So again, Mrs. Burton language, the numbers that go together outside the house here are going to be 3 times 4. If we use our associative property, we can group those together, and then we can group the numbers that are inside the radical and put them together. So if I do that, then 3 times 4 is 12. If we multiply the radicals together, 2 times 18 is 36. So now I've got 12 times the square root of 36. Well, 36 is our perfect square, so we know that's 6. 12 times 6 is 72. Now, I think we can do it without all that writing. If we can do it in our head and we look at this next problem, well, if I look at the numbers that are outside the radical, what's 5 times 4? Well, we know 5 times 8, is 40. Now let's multiply the numbers together that are in the radical, and we've got 3 times 21 is 63. Now, 63 is not a perfect square, but we can simplify that. Remember, that's going to be 9 times 7. And so the square root of 9 is 3. 3 times the 40 that's there, so we're going to get 120 root 7. Now, what happens if I give you some fractions along the way? Well, when we're dealing with fractions, do you remember how to multiply fractions in math past? Okay. Remember, if both of those fractions are in the house, we can cancel. Remember our little shortcut canceling? Okay, so if I look here, then I can cancel the 3 goes into 3 once, and 3 goes into 27 9 times. If I look at my 10 and my 32, well, 2 goes into both of those. So now we can multiply the numerators. 5 times 9 is 45. If we multiply the denominators together, square root of 16, well, square root of 16 is my perfect square, and then we would simplify 45 and get 3 root 5. Very nicely done. Okay, you guys try the last one here. Again, we've got fractions inside the radical, and we're multiplying so we can cross cancel. So 7 goes into 7 once. 14 twice, 3 goes into 3 once, 27 9. So if I multiply the numerators now, I've got the square root of 2 over the square root of 9. Square root of 9 is a perfect square, so there is my final answer. So again, we're going to, if the numbers are outside the radical, Mrs. Burton says outside the house, we can multiply them and put them together. If they're inside the house, we multiply them together and put them back in the radical. And then we see what we can cancel, or see what we can reduce. And then if we have fractions, we can use cross-canceling. Now, we're on this journey of how to figure out how to simplify radicals. And the new one for today is the one with the star by it. I'm going to start at the bottom and work my way up. If we look at the bottom one, okay, that's one of the first rules we looked at. To have a radical in simplest form, the radical has a perfect square factor other than 1. And we've been doing this even today. If I have 4 root 18, 18 is not a perfect square, so we can simplify that, and we're going to take 18 and make it 2 times 9. We know the square root of 9 is 3, so we're left with 3 root 2, and then I can multiply 4 times 3, and get 12 root 2. So we've been doing that already. If we look at the middle one, remember we can't have a fraction inside the radical. As soon as I see a fraction inside the radical, I rewrite it as the square root of the numerator over the square root of the denominator. And then we can simplify from there. Now, the new one for today is this idea of no radicals in the denominator. Now, we're going to learn this process called rationalizing the denominator. So since I can't have a radical in the denominator, I have to get rid of it. Now, if you remember from last week, the easiest way to do that is to multiply a radical by itself. If you remember last week, Mrs. Burton said if we multiply a radical by itself, it takes it out of the house. We've got the square root of 3 times the square root of 3, which gives me the square root of 9, which is 3. But now, if I multiply the square root by itself, whatever I do in the denominator, I also have to do in the numerator. So if you notice, we're really just multiplying this fraction by 1. So as I go across in here, then 5 times root 3 gives me 5 root 3. Again, if the 5 is outside the radical and the 3 is inside the radical, I can't put them together inside. So let's see how that looks like now as we do some problems together. And I'm going to try and show you some little tricks to hopefully help you along the way. So let's look at number 1. Well, did you notice that both of my radicals are the same? The square root of 7 times the square root of 7 takes it out of the house. So this really means I have 4 times 2 times 7. What's 8 times 7? Everybody says 56. Now, if we're looking at number 2, you would say, well, Mrs. Burton, you know, they're both inside the radical. They're both inside the house. If I multiply both of those together, I think you get 245. And then you would have to simplify that radical. And again, you'd have to come up with factors, or you could cake it. But look what happens. If I break this 35 up into 7 times 5, then I can say the square root of 7 times this square root of 7 takes it out of the house, and the 5 stays in, so we get 7 root 5. There you go. Okay, now let's look at number 3. When we look at number 3, when I look at the radical there, that's not a perfect square. So we might have to use some of our divisibility rules to help us to simplify that radical. Well, 2 goes into both of those, or into that. Oh, 121. That works out really nicely. 121 is my perfect square, so that's going to be 11 root 2. And we've still got times 9. And then our final answer here, 9 times 11, because they're outside the radical, gives me 99. And 2 stays inside the house. All right, everybody copy down number 4. Now, when we get to number 4, we're back to distributive property. Okay, back to distributive property. Remember, we're going to take the number on the outside of the parenthesis and multiply it by everybody on the inside. Well, when I look at number 4, I've got square root of 7 times 6. Well, one's in the house and one's out of the house, so they come together, but not in the house. And now the square root of 7 times square root of 2, well, both of those are in the house, so there we go. And now, I can't simplify that any longer. Okay, again, some of you might be thinking, oh, but Mrs. Burton, that's 7 times 2, but that's when we were multiplying. Remember, over here on number 1, we were multiplying, and we could do that. But on number 4, we're actually subtracting, so I can't use that little trick, and so that's the answer for number 4. Number 5, let's see what we can use that product property for to help us here. Now, how do you think, what would be the best way? What factors would be the best set of factors to use for 10? Yep, it'd have to be 5 times 2. And then over here, when we've got 27, we're going to do 9 times 3. All right, so, and when I look here then, wow, this square root of 5 times that square root of 5 is going to take it out of the house. And then 5 times 3, negative 15, root 2. And now over here, this last one, I can simplify that as 3 root 3. And now let's put them together. Negative 15 times 3 is negative 45 root 6. Okay, so it's real important to see and pay attention who's in the radical and who's out of the radical and what we're going to do with them. Let's do a few more complicated ones. Now, if we look here, we've got another fraction. Again, both fractions are inside the radical, so I can cross cancel. So 11 goes into 11 once and 22 twice. 8 goes into 8 once and 32 4 times. So that means I've got the square root of 2 over the square root of 4. Now, square root of 4 is my perfect square, so I can take the square root of that. Final answer. All right, on number 7, we can simplify that square root of 48. Do you remember what I said the best set of factors were? I said 4 times 12 isn't going to help you. That's right. Okay, that's right. We said the best thing to remember here is 16 times 3. Now that 3 is a little hint. What's one way I can break up or simplify using that product property for square root of 39? Yeah, we can say 13 times 3. Now that was important because now guess what happens to those 3's? They can cancel out. Okay, so I've got the square root of 16, which is 4. 4 times that 5 gives me 20 over square root of 3. Now, have we simplified that radical? Oh, did you realize we had a radical in the denominator? So we have to rationalize the denominator. So we're going to multiply by 1 using root 3. So square root of 13 times the square root of 13 gives me 13. And then the numerator, they're just going to join together. Awesome. Okay, now number 8, 320. So I know that 4 goes into 20, but that might work. But it's best to find the largest perfect square we can, and actually 16 times 20 works pretty good here. In the denominator, we're going to have 25 times 3. So let's see what happens. Okay, we've got 16, square root of 16 is 4. 4 times that 15 is going to give me 60 root 20. Down here, this is going to be a 5. 8 times 5 is 40 root 3. Now let's look. Wow, did you realize we can simplify this 20 and make it 4 times 5? So the square root of 4 is 2. So now I've got 120 root 5 over 40 root 3. What do you think we should do next? Yeah, I like that plan. Let's simplify the numbers outside the house. So we've got 12 divided by 4. We've got 3 root 5 over root 3. And now we're going to have to rationalize our denominator. So we've got the square root of 3 times the square root of 3, which is 3. And then we've got 3 root 15. Did you see? That was long and drawn out. Our 3's are going to cancel. So the final answer for number 8 is root 15. Kind of long and drawn out. Again, the way you sequence your numbers may be a little bit different than Mrs. Burton sequences her numbers, but we still should get the same answer when we get to the end. Now, it's an algebra thing, so we've got to throw some letters in there. What's going to happen when we have to multiply with letters? Well, again, I would have you multiply the numbers that are outside of the radicals first. So this is going to give me 5 times negative 2, which is negative 10. And then let's multiply the radicals together and see what happens. And we're going to get m times m, which is m squared, n squared. And now look inside the radical. Is that a perfect square? Sure is. We can simplify it. So here we would get negative 10 mn as our final answer. Same idea with number 2. Well, let's multiply what's outside. Negative r times negative s is going to give me rs. If I multiply what's inside the radicals, well, r squared times r squared gives me r to the 4th. S times s gives me s squared. And they are both perfect squares. This is going to give me r squared s. And if I multiply those by what's outside the house, we're going to have r cubed s squared as my final answer. Well, number 3 is our distributive property. So we're going to take the square root of x times the square root of x to the 5th and get the square root of x to the 6th. And then we're going to multiply that by the 7 as well. So we get 7 root x. Now, do you see that I can simplify something there? This right here is a perfect square. The square root of x to the 6th is x cubed plus 7 root x. Great job. All right, let's go on. Try a few more. Now, you might see some little tricks of the trade along the way. If we can multiply in any order, but if I multiply these two terms to the first two terms together, I'm going to get root 6a squared. Now that's kind of sweet because if you look at the last term, guess what's in? Okay, they both have root of 6a squared times the root of 6a squared, takes it out of the house. So now I've got 2 times 6a squared, which is 12a squared. If we look at number 5, we're going to take square root of 27 and we're going to simplify that. And then that's going to give me 3 root 3. And we've still got 3 times n. And then we've still got 5 times n. So let's look. This square root of 3 times this square root of 3 is going to take it out of the house. We've still got the 3 in front. This n, square root of n times the square root of n is going to take that out of the house. And 5 is the only one left in the house. So we got 3 times 3, 9n square root 5. Now if we're looking at number 6, do you see this parenthesis here? They want me to take the square root of 7n squared. Now remember, we've talked about those are inverses of each other. To take the square root of something and then square it, their inverses are opposites. They undo each other. So this really just means 2n times 7n, which would give us 14n squared. Last slide for today. Now these are a little bit harder. I kind of want you to see what's going to happen when we have to extend the lesson a little bit. If you look at number 7, well, I've got fractions. And if I look up there, I could multiply, but nothing's going to cancel out. So let's see what happens there. Since nothing's going to cancel, we're going to have 3q. And then in the numerator, we've got 3q squared. And then in the denominator, we've got 2r squared. Well, my letters are actually perfect squares, so we can take out a q here and multiply that by the q in front. Remember, this is over 1, so we're going to take out the r, and that means I'm left with the square root of 3 over the square root of 2. All right, so we're going to have to rationalize the denominator here to get rid of that radical in the denominator. So we've got the square root of 2 times the square root of 2, which gives me 2r. And then here we've got 3q squared root 6. That kind of ran into each other, but that's my answer. Okay, now let's look at number 8, and we're going to use our distributive property. Okay, so when I multiply the square root of 6x times the square root of 3x, we get the square root of 18x squared minus, well, that 4 is outside the house, so we're going to leave him there. And then we've got 6 times 8 is 48x cubed. Now, what can we simplify these radicals? So this 18 is going to become 19 times 2 times x squared. So we're going to get 3x root 2. And over here, remember 48, we're going to do 16 times 3 times x squared times x. Remember, previous lesson, if we had an odd exponent, we write it as the even plus 1. So this is going to be, the square root of 16 is 4, times the 4 that's already out there is 16. We're going to take out the x squared, and we're left with 3x in the house. Nice job. Okay, last problem, number 9. Now remember, on number 9, we've got a power to a power going on here. So remember that cubed, let's get rid of the writing so we can see what's going on. That cubed on the outside goes to everybody on the inside. So we're going to have 5 cubed root 2 cubed. It's going to be x to the what? Remember what we do to exponents when we're power to a power? That's right, we multiply x to the 9th. Let's go ahead. This is going to be 125, and let's go ahead and make this 8, and then we've got x to the 9th. We can make this 4 times 2, and x to the 8th times x. So who's our perfect squares? Well, 2 is a perfect square. He's going to come out. 2 times 125 is 250. X to the 8th, that's x to the 4th, and then we've got 2x left in the house. All right, great job.